Hi everyone, today we are going to continue talking about simplifying rational expressions. Specifically, we are going to be adding and subtracting them today. In this video, we are going to talk about finding a least common denominator for rational expressions and then adding and subtracting after we find that common denominator. We are also going to be simplifying complex fractions today. Okay, so the first thing that we need to talk about is when you're trying to add or subtract two rational expressions that have common denominators or like denominators. So you'll see in this example that the denominator of both of these fractions is 5x. So because they have a common denominator or they match, we can go ahead and add or subtract the numerators depending on what the operator sign in between is. So when we do that, we have 12 minus 2 in our numerator, and we're going to place that over the common denominator, 5x. 12 minus 2 is 10, so that's 10 over 5x, and then we need to simplify because both of these are divisible by 5. 10 divided by 5 is 2, so that leaves us with 2 over x as our final solution. Note here that because these two denominators matched, we were able to do that subtraction in this case. Let's look at a couple of problems that are similar. So in this first one, we have two rational expressions that we're adding together, and notice here that the denominators match. They are both x squared plus 1. That means that we can add the numerators together. So we're doing 2x squared plus 2 all over the common denominator of x squared plus 1. Now we do need to think about simplification for this. There is a GCF in the numerator of 2. So if I take out the GCF of 2, it leaves me with x squared plus 1 inside, and then I still have that denominator of x squared plus 1. I have a common factor in the numerator and denominator, so those divide out and leave me with just this 2 as my final simplified answer. Let's do one more of these, a subtraction problem. Now we again have a common denominator here, but I do want to point out that this is a subtraction problem. So when we do this, we have 4x minus, and then this entire 2x plus 7 is being subtracted. All of that's over our common denominator. Now with this subtraction problem, you have to be very careful because this term on the right is a binomial, meaning that there are two different terms in it. So that means that this subtraction is going to be a 2x being subtracted and also a 7 being subtracted. So the first step here is going to be to distribute that negative sign in. So it's 4x minus 2x minus 7. Be sure you distribute the negative sign to the second term as well when you're working on a subtraction problem like this. So continuing onward, you get in the top 2x minus 7 over the denominator of x plus 3. That can't be simplified anymore. There's not a GCF in the numerator or anything like that. So that means we're done. Okay, so now let's do some adding and subtracting when the denominators don't have that commonality, when you have unlike denominators. You'll see in this example, one of my denominators is x plus 2, and the other denominator is x plus 5. Now I'm going to put those in parentheses like we were doing in the last section because this is one unit. This binomial, he is stuck together with that addition sign. This one is stuck together with that plus sign as well. So the first thing we need to do in order to add these two rational expressions together is to find a common denominator. And ideally, we want a least common denominator. So the first step is going to be to do any factoring that we can in the denominators. Now, lucky for us in this example, this is prime. It's already factored as much as can be, and this cannot be factored anymore either. So now we're just going to make our common denominator. So looking at this first denominator here, we have to have the factor x plus 2 in our denominator. Looking at the expression on the right, we also have to have an x plus 5 in our denominator. These two factors don't match one another, so I need one of each of them in my new common denominator. So now we're going to do the second step, which is multiplying to create the least common denominator. So we are going to take our least common denominator that we just came up with, and we're going to multiply this left expression, and then we're going to multiply this right by whatever's missing from the denominator. So on the left here, we have the x plus 2. So this part of the LCD is included, but we are missing the x plus 5. So we're going to multiply by x plus 5 on the top and bottom, because that gives me my common denominator of x plus 5 times x plus 2. On the right-hand side, we have x plus 5. So we've got that one already, but we don't have x plus 2. So we're going to multiply by x plus 2 on the top and bottom, because now my denominator has the x plus 5 and also the x plus 2 of my LCD. Okay, so that means if we're looking just at this one side first, we have x plus 5 times x. I'm going to write it out here in the front. And all of that is over our common denominator, x plus 5 times x plus 2. Now I'm going to write this plus sign. I'm going to put these brackets here just so it's easy to follow for now. When I multiply across the top, I have 4 times x plus 2 all over my common denominator. All right, so now I've got my common denominators, so I need to do some simplifying on the top, and then I'm going to do this addition. So in the first numerator, I have this x that I need to distribute in. So that's x squared plus 5x all over my common denominator. And then I'm going to be adding to that my common denominator, but my numerator, I have to do some distributing. This 4 has to be distributed, so that's 4x plus 8. And now I'm ready to do my addition finally. All of this is going to be over the common denominator of x plus 5 times x plus 2. And then I'm adding. So let's see, I have x squared plus 5x plus 4x plus 8. I have some terms that I need to combine here as I simplify. These two middle terms are like terms, so I'm going to add them together and put this all over my common denominator. Now, something worth note here is that often you are going to have something, an expression that's in standard form in the numerator and factored form in the denominator. You should always take this numerator and factor it to see if anything divides out. Now in this one, when we do this really quickly, we're going to use x plus 1 and x plus 9. There is nothing that divides out. There's nothing that I can cancel. So you can leave your final answer in either of these two forms. You can either put it in fully factored form, or you can leave it in this standard on top and factored on the bottom form. You are welcome to do this quick factoring in your head rather than writing this step if nothing crosses out, but you do need to think about it and check to make sure that you don't have any further simplifying to do. In order to earn full credit, you have to simplify it completely, not just to this step. If it can go further and things will divide out. All right, so let's do some practice here. In this first one, remember our first step is to always see what the two denominators are factored completely. So on the left I have x plus 3, that can't factor, but this guy on the right, this is a difference of perfect squares. It factors to x plus 3 times x minus 3. So now I'm looking for my LCD. If I look on the left, I have to have an x plus 3 in my common denominator because it's here. When I look at the denominator on the right, there's an x plus 3, but I've already got this x plus 3, so I don't need to write it again. It's already a part of my common denominator. However, I don't have in my LCD this x minus 3, so I need to include that x minus 3 in my common denominator here. Okay, so now we are multiplying by the parts that are missing. So if I look on the left here, it has the x plus 3, but it does not have the x minus 3 of my LCD. So I'm going to multiply on top and bottom by it. On the right-hand side, it has an x plus 3 and also has an x minus 3. It has both pieces of my LCD, which means I don't need to change anything about it. So let's just do the multiplication on this left side. We're doing 4x times x minus 3. And that's all over my common denominator of x plus 3 times x minus 3. And remember, this is a subtraction problem. And I don't need to multiply anything on the right, so I'm going to leave him as he is, though I am going to write my denominator in factored form. Okay, so let's see, we need to do some distribution here. That's 4x squared minus 12x. And then this negative sign, I'm going to go ahead and distribute it so that I can do my subtraction. Minus 2x minus 7, and that's all over my LCD. All right, I have some common terms, some like terms to subtract. So that's going to be minus 14x in the center. And then this is not going to factor further, so this one is done. That's prime. Again, it's always a good idea to try to factor the numerator to see if it divides out with anything down in the denominator. Let's try another one of these. Looking at number 4, you have x squared plus 1. This is a prime polynomial. You can't factor a sum of different perfect numbers. So that one can't factor at all. This one on the right has a GCF of 3 though, so if I take that out, then that is my fully factored denominator. So looking across for my LCD, I have to have a factor of x squared plus 1. And over on the right, I have the x squared plus 1 already in my LCD, but I'm missing this 3, so I need a 3 here as well. All right, so let's see what we need to multiply by. On the left-hand side, I've got the x plus 1, but it's missing the 3, so I'm going to multiply on top and bottom by it. The right already has the 3 and it has the x squared plus 1, so I don't need to make any changes there. So multiplying across the top on my left term, I get 6x squared over 3 times x squared plus 1. And I'm adding these fractions. I don't need to change anything on the left-hand side, except maybe writing up my denominator as factored. And now I'm ready to add. So we're going to get 6x squared plus 2 over my common denominator. All right, looking at this one, let's do this one as a good example of more practice factoring the top. This has a GCF in the top, which is 2. When I factor out that 2, I get 3x squared plus 1 in my numerator, and I have this 3 times x squared plus 1 in my denominator. Now these do not cross out, right, because they don't match exactly. So this is another good example of one where there's no further simplifying, and either of these answers would have been an okay place to leave your final answer. All right, let's look at one more of these that has some stuff going on down in the denominator. You have this x plus 8 for a common denominator, but the one on the right needs to factor some, right? So we're going to factor it to x plus 8 times x minus 3, and then we're going to come up with our LCD. The one on the left has a factor of x plus 8 down in the denominator. The one on the right, we've already got this x plus 8 in our LCD, so we don't need to write it again. However, it's missing this x minus 3, so we do need to include that. This means then that our left-hand factor needs to be multiplied by x minus 3 over x minus 3, and our right-hand factor doesn't need to be multiplied by anything because it has everything it needs. So we've got 5x times x minus 3 divided by our LCD plus our right-hand term, which doesn't have anything that we're multiplying in. And now we need to do some simplifying. So I'm going to distribute this 5x first and do 5x squared minus 15x. And then I'm going to add my 4x minus 9, my other numerator. That's all over x plus 8 times x minus 3. I've got some common terms there, so let's see, 5x squared minus 11x minus 9. That's all over x plus 8 times x minus 3. That one is not going to simplify further when I try factoring, so I am done with that one. All right, the last thing that we need to look at is complex fractions. Remember, a complex fraction is a fraction that has a fraction inside of its numerator, its denominator, or in both of those places. So I know when you look at this example, you see a whole lot going on, right? Because there's this big fraction bar, but then there's all of this other stuff too. There's a lot going on in the numerator, there's a lot going on in the denominator. So the first thing that you want to do anytime you have a complex fraction like this is rewrite it as just a division problem, like we were doing in the last section. So my numerator, I'm going to leave as it is. I am going to go ahead and put the 6 over 1 just so it's a little easier to see. So I've rewritten this numerator. Now I'm going to write this division bar as a division sign, and then I'm going to put this denominator over here. And I'm going to write that as 10 over 1 again, just so we've got fractions everywhere and it's easy to see what's going on. Okay, so now let's see what we can do. Because this is a division sign, we're eventually going to need to keep, change, flip, right? But before we do that, why don't we work with these fractions that are being subtracted and these fractions that are being added individually to make it a little bit easier to manage? So if I worry about just this this left side for a moment, I can find a common denominator there, right? And then I can make it one fraction instead of two that are being subtracted. So if we're looking for an LCD there, the LCD is 3, and this one needs to be multiplied by 3 over 3. So when I do that, I get x minus 18, and that's all over 3. When I look at the one on the right, my LCD is x. So this one needs to be multiplied by x over x. So that gives me 10x plus 4 all over my common denominator of x. So just by looking at these individually and getting a common denominator, it made it a significantly less complicated problem. It doesn't look so visually complicated. So now let's keep, change, flip these answers. We're going to keep, or these expressions. We're going to keep the first one the same. We are going to change the division sign to a multiplication sign, and we're going to flip the second expression. So it's x over 10x plus 4. All right, so now we're ready to do multiplication, which means we're multiplying across the top and multiplying across the bottom. So that means we're going to take this x and distribute it. It's x squared minus 18 and 30x plus 12. Then let's see what we can do. We could, oh, did I lose? There's an x there. We could take out a GCF of the numerator and the denominator, so let's do that and see what it looks like. When we take out an x, it leaves us with x minus 18 in the numerator, and in the denominator we can take out a factor of 6. When we divide both of those by 6, that gives us 5x plus 2. And that doesn't simplify at all, right? There's nothing that divides out there. So you could leave your answer in either one of those two formats as your final. Okay, there are a few problems for you to try now, so go ahead and give those Now You Tries a try. In this video, you learned how to find least common denominators for rational expressions and then add and subtract to simplify those. We also did a little bit at the end with complex fractions.